Your engine is screaming at you right now. That ticking sound, that knocking underneath the hood, that faint whine you keep turning the radio up to ignore, that is not just noise. That is metal destroying metal inside your engine block right now. Every single second you ignore it, tolerances are widening, bearings are losing their shape, and heat is building in places your oil will never reach. You take it to a mechanic and you already know what they are going to say. $3,000 minimum. Probably more. But what if I told you there is a powder sitting in your kitchen cabinet right now? A powder that costs less than $1 that silences engine noise permanently. Not by covering it up, not by dampening it, by eliminating the physical cause of the noise at the molecular level. One application, one time, and the noise is gone forever. This compound is a dry, dark gray powder with a slightly greasy feel between your fingers. It occurs naturally in certain rock formations deep underground. It has been used in industrial applications since the middle of the 20th century, and it has a property that no petroleum-based oil product on Earth can replicate. When this powder is pressed between two metal surfaces under pressure, its molecules arrange themselves into flat hexagonal layers thinner than a single human blood cell. These layers slide against each other with almost zero measurable friction. It does not sit on top of the metal like a coating. It physically embeds itself into the metal surface and becomes part of the metal permanently. One application, no reapplication needed. No bottle you have to buy again every 3 months. No subscription. No recurring purchase of any kind. And that single fact is exactly why the people who profit from your engine failing made absolutely certain that no car owner in America would ever learn what this compound is called. The year was 1972. A materials engineer named Dr. Leonard Hargrove was working at Argonne National Laboratory outside Chicago. He was not working on cars. He was not trying to help consumers. He was testing dry lubricant compounds for use inside nuclear reactor coolant pump assemblies. These pumps operated in environments that would obliterate any liquid lubricant within hours. Radiation exposure broke down molecular bonds in conventional oils faster than they could be replenished. Hargrove needed a compound that could survive these conditions indefinitely without any liquid carrier whatsoever. Over 14 months, he systematically tested 23 different mineral compounds under extreme pressure and radiation exposure. 22 of them failed. They broke down. They lost their lubricating properties. They degraded under the conditions. One compound did not. This compound reduced surface friction by 89% under loads that had completely destroyed every other substance he tested. But the friction reduction was not even the most remarkable finding. When Hargrove placed treated metal samples under an electron microscope, he observed something he had never seen in 19 years of materials research. The compound had not simply coated the surface. It had physically migrated into the crystalline structure of the metal itself. It had filled every microscopic valley, every scratch, every imperfection in the surface, creating a mirror-smooth molecular layer that was now permanently part of the metal. It was not on the metal. It was inside the metal. Hargrove submitted his complete findings to the Department of Energy in a 1973 internal technical report. Document reference DOE INL 7734. The report was stamped for institutional use only. It was not classified. It was not restricted. It was simply never distributed beyond the walls of the laboratory. It sat in a filing cabinet in a basement archive in Argonne, Illinois for decades. Nobody outside that building ever read it. What Hargrove discovered in that lab is only half of this story. The other half is what happened when the automotive industry in Detroit found out what this compound could do. That part of the story has never been told publicly until right now. Stay with me because the next few minutes are going to fundamentally change how you understand every single repair bill you have ever paid in your life. Before Hargrove ever touched this compound, the United States military had already been using it for nearly 2 decades. The US Air Force integrated it into jet turbine bearing assemblies beginning in the late 1950s. The F-104 Starfighter maintenance protocol specifically required this compound in all primary turbine shaft bearings. Those shafts spun at 25,000 revolutions per minute at sustained temperatures exceeding 900 degrees Fahrenheit during normal operation. No liquid oil on Earth survives those conditions for more than a few seconds. This compound survived them indefinitely. Then NASA took it further. In 1971, engineers preparing the lunar rover for the Apollo 15 mission needed lubrication for wheel hub assemblies that would operate in the vacuum of space. No atmosphere, no moisture. Temperature swings from positive 250 degrees Fahrenheit in direct sunlight to negative 280 degrees Fahrenheit in shadow. Every conventional lubricant ever created would either freeze solid or evaporate instantly under those conditions. NASA Technical Note TND 6217, published in March 1971, documented that this compound maintained full lubricating performance across the entire temperature range without any measurable degradation whatsoever. It was inside the wheel assemblies of every lunar rover on Apollo 15, 16, and 17. It rolled across the surface of the moon and performed flawlessly every single time. And it was not only the Americans who knew. Declassified Soviet military documents released after the fall of the USSR in the 1990s revealed that the Soviet Navy had independently discovered the same compound in the early 1960s. They used it inside torpedo tube mechanisms on nuclear submarines. The KGB Technical Directorate had filed reports on its effectiveness as early as 1963. Two global superpowers, locked in the most intense military competition in human history, both independently discovered this compound, both used it in their most critical military systems, and neither one ever told their civilian populations it existed. Now here is where the story turns dark. By 1975, small aftermarket additive companies had begun quietly selling this compound through industrial supply catalogs. Not auto parts stores, not consumer retail outlets. Industrial catalogs that only machinists, factory maintenance crews, and equipment operators ever saw. A small company in Ohio called TriCoat Industries changed that in 1976. They released a consumer packaged product containing this compound suspended in a light carrier oil. It came in a small bottle. It cost $1.89, and they marketed it directly to car owners for the first time in history. Within 6 months, something unprecedented started happening across the Midwest. Mechanics were reporting that engines with persistent knocking and ticking noises were going completely silent within 50 miles of a single application. Customers who had been scheduled for expensive engine rebuilds were calling to cancel. A transmission and engine shop owner named Frank Delaney in Akron, Ohio, told a trade magazine in early 1977 that his rebuild orders had dropped by 40% specifically among customers who had used the TriCoat product. 40%. In 6 months. From a single bottle that cost less than $2. Now understand the economics of what was happening. By 1975, the automotive repair and maintenance industry in the United States was generating over $90 billion annually. Oil change franchise chains alone represented a $12 billion segment growing at 8% per year. Dealership service departments at most major franchises were generating more annual profit than the vehicle sales floor. The entire financial architecture of the American automotive business was built on one foundational assumption. Engines wear out. Engines need regular service. Engines eventually fail and need to be rebuilt or replaced. An engine that does not wear out destroys that entire model. An engine that lasts 400,000 miles instead of 150,000 delays a new car purchase by 10 to 15 years. An engine that does not knock does not need a diagnostic visit. An engine that does not burn oil does not need additives sold at $14 a bottle at the parts counter. A single $2 application was threatening to collapse a $90 billion annual revenue stream. TriCoat Industries went out of business in 1978. No public explanation was ever given. Their product disappeared from every catalog. No major retailer picked it up. No national chain offered to distribute it. The compound itself remained available through industrial chemical suppliers, but those are places no ordinary car owner would ever think to look. The compound was not banned. It was not recalled. It was simply made invisible to the people who needed it most. If you are still watching right now, you already understand more about engine protection than most professional mechanics are ever taught in their entire careers. Dealership training programs never mention this compound. ASE certification courses skip it completely. What is coming next is the exact application method, the precise measurements, and the step-by-step process. And I promise you it is simpler than changing a headlight bulb. Subscribe right now and share this with anyone you know who is about to spend thousands of dollars on an engine repair they might not actually need. In 1994, a tribology research team at Virginia Tech conducted a controlled independent study comparing this compound against 8 leading commercial engine oil additives sold in major auto parts stores across America. The study ran for 14 months. Testing was performed on matched pair engines running continuous dynamometer cycles carefully calibrated to simulate 200,000 miles of real-world driving under identical controlled conditions. The results were not close. Engines treated with this compound showed 71% less cylinder wall wear than the best-performing commercial additive in the study. Bearing surface degradation was reduced by 58%. Metal particle contamination measured in oil samples was 64% lower than any petroleum-based product tested. Projected engine lifespan, based on measured wear rate extrapolation, exceeded 500,000 miles. The study was published in the ASME Journal of Tribology. It was peer-reviewed. The methodology was sound. The data was completely solid. And then nothing happened. Not a single automotive manufacturer acknowledged the findings. Not a single major oil company responded. No follow-up research was funded by any industry source. No consumer product was developed based on the data. The paper accumulated citations only in industrial engineering and aerospace lubrication contexts. It was referenced by researchers working on mining equipment, turbine assemblies, and satellite mechanisms. Car owners never saw it. Mechanics never heard about it. It might as well have never been published at all. A shop owner in rural Georgia who goes by Dale has been adding this compound to every customer engine that comes through his doors for 18 consecutive years. He buys it in bulk from an industrial chemical supplier. His cost per application is approximately 80 cents. He told a trade forum in 2019 that across 18 years and over 4,000 engines treated, he had experienced exactly 2 engine failures. Both were in vehicles with pre-existing cracked blocks. Neither failure was wear-related. Every single engine he treated that did not have prior structural damage was still running when those customers eventually sold or traded the vehicle. A long-haul trucker running a Cummins diesel engine reached 1.2 million miles on his original engine block. He had been treating the engine with this compound every 100,000 miles since the truck was new. When his mechanic pulled a valve cover for a routine inspection at 1.1 million miles, he told a trucking magazine that the internal components looked like they belonged in a motor with 50,000 miles on it. His exact words were, "My mechanic could not believe what he was looking at inside that engine." The compound is called Molybdenum Disulfide. Its chemical formula is MoS2. It is available right now as a fine gray powder or a pre-mixed liquid suspension at any hardware store, any farm supply outlet, or online from dozens of suppliers. Food grade or technical grade both work identically for this application. Here's exactly what to do. Step 1. Purchase MoS2 powder or liquid suspension. The powder costs approximately 80 cents to $1.50 for the amount you need for a single engine treatment. Liquid suspension costs approximately $2 to $4 for a 4-ounce bottle. Step 2. Warm your engine to full operating temperature by idling for 12 to 15 minutes. This is critical. The heat opens microscopic pores in the metal surfaces and allows the compound to bond far more effectively than it would on cold metal. Step 3. Remove the oil filler cap on top of your engine. Add 1.5 to 2 tablespoons of powder, or 3 to 4 ounces of liquid suspension, directly into the oil fill opening. Step 4. Replace the cap and let the engine idle for another 10 minutes. Do not rev the engine during this period. Let the oil circulate the compound through every internal passage naturally. Step 5. Drive normally for 50 to 75 miles. During this initial driving period, the compound completes its permanent molecular bonding process. It fills microscopic surface imperfections across your cylinder walls, crankshaft journals, cam lobes, lifter faces, and all bearing surfaces throughout the entire engine assembly. After 75 miles, the full protective layer is permanently established inside your engine. It will not wash out during oil changes. It does not degrade with heat. It does not break down over time. It is physically and permanently part of the metal now. One honest note before I close this. This compound is not a resurrection tool. I am not going to lie to you the way the industry lies to you. If your engine already has a spun bearing, cracked ringlands, or deeply scored cylinder walls, no additive in existence can reverse that kind of structural damage. The real power of this compound is entirely in prevention and early intervention. An engine treated early, before significant wear accumulates, will outlast any untreated engine operating under identical conditions. That is not a marketing claim. That is not a sales pitch. That is 5 decades of engineering documentation, military field reports, NASA technical notes, and peer-reviewed published science. Your engine is wearing down right now, with every idle at a stoplight, with every cold start on a winter morning, with every single mile you drive. The compound costs less than a cup of coffee. The knowledge I just gave you costs nothing. What costs everything, what costs you thousands of dollars over the life of every vehicle you will ever own, is simply not knowing this exists. And now you know. If this changed something for you today, subscribe and share this right now. Every single share is one more person who escapes the cycle of unnecessary repairs that a $900 billion industry built its entire fortune on. The next video goes deeper into something even more aggressively hidden from consumers than this. What is coming is heavier than everything I just told you, and it is heavier than you expect.